2.5, last section of the chapter, is really just quite a few proofs, but it's proofs when you're dealing with angle relationships and also segment relationships, like if you're told something's a midpoint, you can use that in proving things. Tomorrow I will not be here. We're going to do a proof worksheet in class. That will count as one of your 2 CK12 grades. Okay. The other is a CK12 assignment. So 2 CK12 assignments. One is on the computer that you can do whenever you need to do it, and then the other you'll do in class tomorrow in the form of the worksheet that you'll get. Okay. Right now I feel like, since I won't be here tomorrow, Thursday we'll kind of make a review day, and then Friday we'll do a quiz 2.3 through 2.5. And then we'll be looking at the chapter test next week, because that's the end of the chapter. Yes? Okay. So you'll just have to make the quiz up. Yep. If you are not here for class tomorrow, I did put the worksheet on Canvas. Okay? So if you miss the worksheet tomorrow in class, then you just need to do it yourself on Canvas. Yeah. It's up to you. Yes. Okay, so I'm going to, in the book, they did they did several proofs for you if you read the textbook. One of the ones that they did, just to kind of show you how these work, I'm going to use green today apparently. That's not drawn very well, but you get the idea. I know. And we're told that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, and they want us to prove angle 1 is congruent to angle 4. Okay, so anytime you set a proof up, you always start with 2 columns. 1 statements, and 1 is reason. What's the first statement you always put in there? The given. And this is what I was given. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Given. And sometimes it helps to put like a statement number that goes with the reason number. On Big Ideas homework, you're just doing matching, but on the worksheets tomorrow, you're going to have to write these. Okay, so, and I may give you like all the statements, and then you have to write the reasons, or I give you different reasons, you have to write the statements, that kind of thing. So sometimes it helps to put numbers on them. Okay, so if I were to go to my drawing and actually draw out what this says, this angle and this angle have the same measure. This angle and this angle have the same measure. I'm going to do that, because I don't know that anything's related to the other side. I just know what I'm given. We good so far? What I'm ultimately trying to prove is that angle 1 and angle 4 are congruent. But it's not obvious from my drawing that that's true yet. So I'm going to have to go through a few steps to show that. Okay? So what I can do is say, my second step, I could say angle 2 is congruent to angle 3. Why is that? So I would say vertical angles theorem. Okay, so now I know 2 and 3 are congruent, right? So I could write this. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Angle 3 is congruent to angle 4, right? Because 3 and 4 are congruent, that was given. 1 and 2 are congruent, that was given. This was I just proved by vertical angles. So if 1 is congruent to 2, 2 is to 3, 3 is to 4, what could I use to say, I'll just say therefore angle 1 is congruent to angle 4. Why? This is really my statement right here. I'm just showing you the kind of the work to get there. Why is angle 1 congruent to angle 4 if I know all of this? What property lets me say that? Transitive property of equality. Yep. Okay, this was what I was supposed to prove. Remember, the last statement is always what you were supposed to prove, and I just did that. So I'm done with that one. I already did, transitive property of equality. Uh-huh. Yep. So let's try another one. Okay, everybody's going to try this on your own. 2-column proof. Given AC and BD are perpendicular, and given angle 1 is congruent to angle 4, prove 2 and 3 are congruent. So try this on your own, and then we'll do it together. It's on the board.
Oh, that one. Not my day. What is it?
Yeah, that's fine. Someone plugged their phone into my charger?
Yeah, I'm sorry. You can unplug it.
Okay, because mine's about to die, so I need to plug mine in.
I could have just used it. Yeah. It was just there and it was unused.
What the hell was that?
The upside down T? The same.
Perpendicular,
So it's the same.
not the same. Perpendicular
Perpendicular, not the
means
same.
they come together at 90-degree angle. They're perpendicular.
So
They're not equal to each other. It means they're perpendicular to each other.
The only hard part is trying to figure out how to explain the
I don't even know where
That's the
it's
only
from.
hard part. It's so easy.
I have no idea what I'm doing.
How do you know they're bisected?
Well, logically speaking, if angle 1 and angle 4 are congruent, and ACBD are whatever that word was, because I forgot, then those the line connecting angle 1 and angle 2 and the line connecting angle 3 and angle 4 are going to be at the same
You work on your
measurement.
proof, and then you can.
I just don't know what the word, what the phrase is. I know it's congruent, but I just
when you do a proof, you're just breaking it down into one statement at a time. Don't get overwhelmed thinking you've got to do everything at once. We know AC is perpendicular, so I'm going to go ahead and mark my drawing. I know that's true. I know 1 and 4 equal, even if they don't look it. I know that's true. So most of the time with a proof, you're going to have to use what you're given at some point. They gave you that they are perpendicular for a reason. And sometimes when I do these, I just kind of start writing down what I know, given what I'm given. Why? You have to logically tell me why. Okay, so what I might say for my first statement, I've got to say AC is perpendicular to BD, and angle 1 is congruent to angle 4, given.
Half that much.
Okay, so the fact that they're perpendicular means that the measure of angle 1 plus the measure of angle 2 is 90, and the measure of angle 3 plus the measure of angle 4 is 90, right? Definition of congruent angles. Congruent, complementary, sorry. Because they're complementary, right? Now what can I do if I've written that?
And like set them equal to each other?
Well, they're already set equal to each other. What equal to each other? I already did that. That's the given.
2 and 3.
Why are 2 and 3 equal given this?
Because 1 and 4 are.
So what did you do to show that 2 and 3 are equal?
It just makes sense because the angle of 4 minus 90.
Well, what if I substitute in, I could say the measure of angle 4 plus the measure of angle 2 are 90, right? If I substitute 4 for 1, and then I know the measure of angle 3 plus, I already said that, I don't have to say it again. I know 3 plus 4 is 90. So I know here, angle 3 is 90 minus angle 4. So let me get the reason here. Angle 4 plus angle 2 is 90. This is substitution. Property of equality. Now I know angle 2 equals 90 minus the measure of angle 4. I know angle 3 equals 90 minus the measure of angle 4. Right? If I subtract angle 4 from both sides, I get angle 2 is 90 minus angle 4, and angle 3 is 90 minus angle 4. You see these two? If I solve for angle 2, I subtract angle 4 to both sides.
Yeah.
And I get angle 2 is 90 minus angle 4. And here, angle 3 is 90 minus angle 4. That's the subtraction property of equality. Now, if angle 2 is 90 minus angle 4, and 90 minus angle 4 is angle 3, what allows me to say angle 2 is equal to angle 3? What property?
Vertical angle property.
There's no vertical angles in this drawing. Okay, the transitive. Remember the transitive property. This is simplified. If x equals y and y equals z, then you know x equals z. So it's the same thing. If 2 equals 90 minus the measure of angle 4, and the measure of 90 minus angle 4 is 3, you know 2 equals 3. transitive property. So as I said when we first started talking about proofs, when you're doing proofs, a lot of it you can do in your head, and it's obvious. All of you said, well, obviously 2 and 3 are equal, if that's true. Proofs are actually writing down every step to prove that that's true. What you actually go through your head, putting a statement to every, or a reason to every statement.
I did not look that through my head. I did not.
How did you get, okay, so if you were looking at this drawing, and I wanted to ask you how you could prove 2 and 3 were equal, what would go through your head? What would your statements be? Given what we're given. We're given the 2 are 90 degrees, and we're given the angle 1 and angle 4 are equal. Why? What does?
All of them together equal 180.
Okay, all of them together have to equal 180. So what would... Now what?
So if they all equal 180, 2 has to equal 190, and we can divide that by
2 equals 190. What do you mean?
like 2 angles have to equal. Like B and C.
These two have to equal 90.
Yeah.
Because why? What has to equal 90?
1 and 2.
1 and 2 have to equal 90.
And 2 and 3 and 4.
Okay, and these two have to equal 90. Okay,
All that's equal.
Yeah.
okay.
1, 2, 3, 4. And just divide that. That's how I like it.
Okay, but if these are equal, these could both be 30 degrees. They don't have to be 45 degrees. They don't have to be equal to, 3 and 4 don't have to be equal. That wasn't given to us.
See, like, I look at it as like, if angle 1 and angle 4 are the same,
Okay?
are
I guess-
congruent, and then AC is AC is whatever.
Perpendicular.
Perpendicular to BD.
Okay.
Jesus. Then that means that angle, like the wall of angle 1 and angle 2, and the wall of angle 3 and angle 4 are going to have to be at the same measurement, meaning that angle
They
2
both
and
have to
angle
equal
3 are
90.
going to be
Okay.
the same degree.
So that's what I said. Angle 1 and 2 have to be 90. Angle 1 plus 2 are 90. Angle 3 and 4 have to be 90. That's what you just said.
Yeah.
Together they have to equal 90 degrees. So that's that statement there. So,
Yeah.
okay, I'm just writing down your logic in the proof. So you said that these two have to be 90 and these two have to be 90.
Yeah.
Okay, we've got that. I've got that in the first step.
Looking at this problem, I would have said to myself, okay, so 180 divided into 4.
But these aren't all
They don't
equal.
have to be equal.
I know they don't have.
I know. So you've got to only use what you're given. You can't use any assumptions.
The thing is,
That's
what
what
we're
I
given
dislike.
isn't numbers, it's just angle. Angle 1 and angle 4.
Okay, so let's put a number in. They're equal, so they're both 30. I'm just putting a number in. So now, how can I prove that 2 and 3 are equal? Using a number. If that helps you, use a number.
Oh, yeah, that helps out way more.
Okay, so what would you do in your head?
Add 1 and 4 and then divide.
Take 90, subtract it by 30 from each side, and then you.
Well, Ethan, if you're using 180 degrees, and I add 1 and 4, that gives me 60, so there's 120 left. But I'm not told those two are equal, so how can I use that to prove that they're equal? You've got to use what you're given, which is that the two are 90. Forget the 180, because we were given the 2 and 90. Okay, so if this is equal to this, and let's use numbers, what does this angle have to be? 60. Why?
60 plus it has to be
Math.
Because angle 1 plus angle 2 has to equal 90. And angle 3 and angle 4 have to equal 90. Okay. So if I do that, now if what I did next is I just substituted in the fact that 1 and 4 are equal. I said, well, if angle 1 and angle 2 have to equal 90, that means angle 4 and angle 2 have to equal 90. Right? Because they're the same angle. You follow? 30 plus 60 is 90. 30 plus 60 is 90. These two are equal, so I just substituted this measure in here. Because I'm not given a measure, I'm just showing you the numbers to help you formulate this in your mind. Okay? So if I know these two are equal, this plus this is 90, this plus this is 90, then I know this angle and this angle have to be equal. It's taking the steps that you automatically jump to and putting reasons with it. Let's try another one. We'll try another one.
I really wish
I
we could
promise
do it in our own words.
no one in geometry has ever said proofs are my favorite thing. I promise. That's
If I could do it in my own words, this would be so much easier.
okay. Let's do.
Should have been born center so you could have invented shapes.
I invented the circle.
I discovered the circle. That's that. I discovered that works.
Dude, that works.
What? Do like the lines.
Okay, try this one.
Just drawing, I missed it.
Oh my gosh, okay.
It's a line to be able to set it as supplementary.
Okay.
Can I just draw a line that
I
way?
think I got it. Low key.
Just to make it vertical angles and
No, no vertical angles are used in the making of this proof.
It'd be so much easier.
See what you did there. It's not a perfect rectangle.
Well, it is. I just didn't draw it very well.
Wait, oh, well, you put the right angle measurement thingies in those two corners, but not the other two, so I figured.
It's
the other-
assumed. I mean, you can assume from that
Okay.
that it's right. But you shouldn't use any of that
It won't matter.
to help you with this problem.
Well, I like to have all my
Will you low
information.
key come help me?
So would you just put like?
Because like I think I'm getting it, I don't want to fall off.
Low key not.
But if I'm not getting it, just tell me because
Okay, what is that called?
Supplementary, definition of supplementary angles.
May I use the restroom basically?
Yes.
Yeah.
Okay.
Am I
So
getting
far,
somewhere?
you're getting somewhere.
So that means I'm.
Relatable.
If it's a straight line right here.
Oh,
If you want to-
scroll down. Oh, wait, I forgot. We don't write that down.
What is this called? Do you need to switch them around? No, that's called.
I probably do, but I'll wait for everybody and then we'll go through it together. You can see how close you are.
Is 2.4 due tonight?
Yes. Uh-huh.
Thank you.
Ever make it to this step?
No. Oh wait, yeah, that's step. I thought you
my
already went
goodness.
past
No.
He's like, Jesus.
Okay. Now, a lot of you, several of you that I looked at, said that you could say angle 1 plus angle 2 equals 180. That is a true statement, but technically in a proof, you've got to show that they're aligned before you can jump to the fact they're equal to 180. So it seems strange, maybe, but you're going to have to say angle 1 and angle 2 form a linear pair. And angle 3 and angle 4 form, you get the idea, a linear pair. And that's just definition of linear pair.
Would we get it wrong if we said?
No, but I'm just showing you, technically, you've got to show that it's a line before you can say they're supplementary. You know what I mean? Because remember, the proof has to be standalone.
that. Any way to drop out of this class?
Okay, number 3, angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. That's also definition of linear pair. I mean, technically, I should have said step 3 is angle 1 plus angle 2 are supplementary. Definition of linear pair. Then angle 1 plus angle 2 equals 180. Definition of supplementary angles. You see, I mean, basically every single step has to be defined. But we'll just go to this for the logic of the proof here. Okay, so we know these two are 180. These two are 180. We know that 1 and 4 are equal. 1 and 4 are equal. So like in the last proof, I could go ahead and substitute in that substitution property. Okay, now I could go ahead and solve for angle 2. It's not angle 180 minus angle 4. And angle 3 is equal to 180 minus angle 4. So I'm looking at these two. They both have 4 in them. Angle 3 is 180 minus 4. Angle 2 is 180 minus 4. So because 2 and 3 are equal to the same thing, by the transitive property, 2 has to equal 3.
So we could just put
Yeah, so this is subtraction property. The reason I subtracted angle 4 from both. Then 6, I could just say angle 2 is congruent to angle 3 because of transitive property.
Proof questions are going to be on the quiz.
Maybe 1. And on the quiz, usually, and even the test, I usually give you statements and you have to just tell me the reason. You don't have to write the whole proof yourself. Big Ideas is the same way. They're going to give you statements, and you just have to drag the statements and reasons up.
On the 2.4?
And in this one, 2.5.
Because last night I got to 2.4 and I kept reading
What was it?
the 6.
Well, we did proofs. So I did an introductory proof yesterday.
Introductory, but not this.
Right.
That's what we want.
Okay. Well, 2.4 is due tonight, so you have the rest of class. If you want to pull it out, I can help you with that last pull out 2.4 on your Chromebook. I can help you.